I'm excited to be here. Let me go ahead and share my screen. So screen 2, there. Whoop, we can do this. Now we should only see the slides. Are we good? Slides? All right, and not presentation mode. Let me move the Zoom controls out of my way. All right, excited to be here, everyone. Nice meeting you. My name is Morteza. Last name is Karimzadeh. Thanks, Rashid, for saying it correctly. And you're always welcome to say hi if you're on campus, see me around. Welcome to CU Boulder if you're new. And if you're not, best of luck with your research topic. Today I'll provide a very quick overview of some of the stuff that we've been doing recently, right? This is not really a research presentation, so please don't expect that you will understand everything. Just a flyby of different projects, and I'll try to be done in less than half hour, and that's my absolute maximum, so that I can leave some time for interaction, even maybe earlier. Is that a good timeline? We have 45 minutes, right?
We actually have an hour.
Oh, great. I still would be happy to, give everyone the lead. If anyone's interested, we can go into more detail. I will not try to really make the case on why these projects that you're about to see is important. Just rest assured that it was important enough for multiple funding organizations to throw a bunch of money at them at some point, either in the past or even right now. So everything that I showed today is out of a funded research projects. That being said, this is not the only things that we do. There are other projects. Some the funding has expired, and I'll be happy to talk about those as well if you're here if you have questions about the work I've done in the past. My tenure home is in geography. I have several PhD and master's students, as well as a postdoctoral scholar working under my supervision. At the moment, I have one PhD student advising computer science. So even though my home department is in geography, I could advise or co-advise through computer science, and that will be your degree. So if you see geography attached to my name, don't worry, your degree will be in computer science, and so will be the research expectations as well as the educational milestones. So why have I picked this topic? Spatial dependence, nonlinearity in the area of artificial intelligence and deep learning. I want to quickly simplify, actually oversimplify things a little bit, just for the sake of argument, and talk about modeling. That we usually do predictive modeling. We are after some sort of target variable, right? And we use a bunch of independent variables or features to do the prediction, right? Now, in spatiotemporal modeling, you also take full advantage of the spatiotemporal autocorrelation as well as correlations to improve your forecasting or explainability of the models. Now, a bunch of models coming out of econometrics, geography, applied math, statistics, actually, they look at spatially varying relationships and spatially varying models to different degrees. Sometimes you model a phenomena as not a stationary process throughout space. Sometimes only the features are not stationary, and so on and so forth. So it can be different levels. Really, I don't want to get into the details of things, but one way of looking at nonlinearity.
He's amazing.
But can you hear me? Oh, I'll put things. Okay, great. Whoever put themselves on mute. Okay, where was I after 10 hours of work? All right. So we need to figure out what a good model specification is in this case, and the spatial variation makes it a little harder, especially with potential overfitting to a region and not generalizing to another. Now, deep learning, and let's say artificial intelligence, but deep learning to be specific, came in and really helped us model those nonlinearities, right? Through multiple nested layers, either convolutional or really vanilla deep learning networks, where we are extracting features in the earlier layers and then high level features and then the target, all through this application of nonlinearity, right? And then even a global model is sometimes, not sometimes, most of the time is better able to do the modeling of a process that we used to think about spatial temporally varying, right? But I told you that this is a simplification. So I started with modeling space, a model that varies in space, and then ended up with this simple neural network that I say, well, one global model, but it's so good at picking up nonlinearities that maybe with one model we can do predictive modeling. And in reality, there is usually a combination of both, especially in the context of deep learning. Convolutional neural nets are an example. Graph neural networks are another example. And when we have temporal dependence, we certainly want to take advantage of that using recurrent neural networks, again, either embedded in graph or convolution or simple LSTMs on their own. I'll give you a few examples of what our research has been looking at in the past couple of years. First, short-term disease forecasting, specifically COVID-19. So we were one of the teams active with the COVID-19 forecast hub. This effort is still ongoing. If you don't know, in the US, short-term forecasting of the disease was coordinated by the central repository hosted at the University of Massachusetts Amherst, where different models from Facebook AI to Google Brain to Columbia to Harvard to us, we would submit a weekly forecast given previous data. Now, some teams used mechanistic compartmental models, some teams, fewer of those, such as us, use deep learning, for instance. And really, the point of these forecasts was to do all of these, to inform public health interventions, right? Because the disease is affecting different areas at different times. And then if we had a little bit of an advanced signal, we could do interventions in a more timely manner. We were on the modeling team, right? Not on the public health communication side of things. But as I'll show you in a second to you, this effort, especially early on in the pandemic, really exposed a whole lot of gaps that we have in the science of this, especially now that we can apply deep learning to it, or machine learning for that matter, right? And the models that we use are using both historical data as well as a bunch of demographic variables. But more importantly, we are really interested in bringing in the spatial lag into modeling, right? So if you have new cases, let's say in your county or state this week, how much of it was from your own state, how much of it was a spillover from other states or other counties? You always saw the maps of cases or hospitalization or deaths during the pandemic showing some sort of spatial pattern, right? Usually there are areas of hotspots. And how do we bring the spatial variation in our modeling to then perform better? And we did an okay job. I'm just showing you a screenshot of forecast hub evaluations. They go look at these models, and our team is usually top 4, top 5, usually first. But let's just say top 5. Sometimes we have the best performance week after week, but again, this is kind of the surface. So this is not my evaluation. I'm just showing you how the hub folks have seen this. There's a couple of papers on Google Scholar. One's in Nature, and then the other one is in the International Journal of Data Science and Analytics that you're welcome to review if you want to learn more about our work. There's a couple of papers also close to submission that haven't been out there. But we essentially ended up we simplified our models a whole lot, and using LSTM, we could capture a whole lot of variation. But this problem is not closed. There is a lot of gap in there. This figure is from before we started contributing to the forecast hub, and the black line is the actual cases. The blue line or the confidence intervals are the predictions. And as you can see, that the case forecast didn't do all that well. This is the ensemble of all models, not ours, right? Every model on the hub before we started contributing. I'm not saying after we started, everything was, rainbow and unicorns, but still the same challenge kind of persists in that when there is a change in trends, right? When there's a surge or there's a peak or there is, again, a sudden change in trends, a flattening of the cases, the forecasts don't perform all that well, and that's when we need our forecast. So, one of the problems right now we are working on is to customize the loss function that we train the deep network with to then help improve that. I'm very interested in the potential of spatial temporal graph neural nets, learning on graphs in which we could actually take advantage of the spatial and temporal dependence for these kinds of modelings. We haven't done some basic work or transfer learning, when there is a new variant coming in. Well, how long does it take for the model to update itself and keep up and catch up compared to, let's say, an SIR model with the same information available at the time, right? And this custom loss function is exactly what I just explained that we are also working on. So there are potential little research questions that we can tackle in this domain. I'm going to move on to my next project that I want to present, and it's called downscaling air pollution. Really broadly speaking, downscaling might be a little bit of a vague term to you. It's really not much but super resolution, essentially an interpolation problem, right? So today you might have noticed the smoke out there. And there are satellites around the planet that are measuring these, but look, they are looking at a column of data, right? We are not reading in the column. We are sensing that it's a cube around where we live, and that's our exposure level. So how to go from this columns of air measurement to what an air quality station would see on the ground is kind of what this project involves. This is in collaboration with National Jewish Health, who has expertise in pulmonary disease. It's located in Denver. We are the modeling team to then work with these satellite data products to then come up with air pollution measurements. For this kind of project, if you decide to work on this, you need to have a little bit of spatial data handling skills, I have to guess. Otherwise, it may be a little bit of a steep learning curve, right? If you don't know any GIS, this project might be a little harder for you, even though we have processed a lot of data and you could work, let's say, with the NumPy arrays. I should have added that my forecasting project was also funded by multiple organizations, including Population Council in New York City. But when it comes to this air pollution downscaling, first of all, we want to characterize human beings' exposure to air pollution from particulate matter 2.5 to PM10 to ozone to NOx, you name it. There's 4 or 5 primary pollutants. And from there, our colleagues will use these products to then characterize the health outcomes of several national cohorts for which they have data on. On their own, these data sets usually become, prominent papers and data sets that others can use. So there is a whole lot of room in the applied research area where we would just generate some of these data sets. We have worked on some of them. We're still working on some. And then there is some methods questions there as well, right? When there is cloud in the sky, some of the satellite products don't exist. And how do we do this interpolation, downscaling in the case of missing data? How do we do smart imputation using spatial temporal variation? Again, going back to what I showed you on my first slide, how do we take advantage of this spatial and temporal dependence? Same with the applied side of things. Any modeling effort that I've seen at best has used a random forest model, right? This is all very new. This has been happening in the last 2-3 years because the data products are new. Now we have this ability to characterize air pollution at places where we don't have sensors, right? But those models usually don't take advantage of the spatial dependence, right? At best, temporal is what we are doing, but it's a very essentially point-based sample. So for one point, you have the air quality station reading on the ground what a sensor is observing. And for that very same point, you have a bunch of satellite data products as well as other features that you can use. But these points are distributed in space. And what your sensor is reading here is perhaps going to be telling us something about what a sensor, let's say 5 kilometers from here, would read. So there is a whole lot of potential there. Moving on to the next project, yeah, this one also will need some, even more actually. This needs some GIS skills. So for folks who have GIS literacy, this might be interesting working with spatial data. So this is funded by the NSF. The idea is to use heterogeneous data sets in the Arctic to generate sea ice maps. And again, we are just using a convolutional family of deep networks for this matter. And the idea is to use these data sets, data products called SAR, synthetic aperture radar, right? These go through the clouds. They are a different kind of imagery than your day-to-day optical, to then do sea ice mapping. The problem that we have in there, well, I shouldn't say problem, the challenge that we have in there is that sea ice is actually moving. So you have a moving target. Not only is moving, it's morphing and changing, it's freezing, it's melting, and it's of extreme importance not to just climate modeling by the users, but also shipping and navigation. That's why this whole sea ice mapping to this day remains a manual effort. There are national ice centers around the world, one in the US, which is a joint center of NOAA and Navy, that has sea ice analysts, people with master's degrees, that every week are looking at the SAR imagery and drawing polygons of different kinds of ice, different thicknesses of ice, so that then ships can navigate in the Arctic or, for operations. And climate scientists also use those same data sets for analysis. But yeah, what if we could automate at least part of this? And in fact, those national ice centers want us to automate their job because they have better things to do with their lives. I'll show you an example, right, a segmentation result of this SAR imagery to what the label would have been, right, for an ice and no ice scenario, binary labeling. And this is our prediction. And sometimes the image is very, very noisy, just like this. And even a human can't really look at one image and determine the ice flows, but through larger contexts, you can. So I'm just showing you a binary ice, no ice example. There are a little more sophisticated cases in which our polygons actually come with multiple labels. And not only it's a multi-label classification problem, it's in fact a multi-task classification problem segmentation problem. And segments are the same, but the way the labels are assigned and expected of the model are very specific to this problem. So that's where the methods contribution comes in that it's a specific problem. It's not a cats and dog fashion in this kind of data set that you can just take it, run and CNN on and run away with it. There is room for methods contribution here. But sometimes it gets really messy too. Look at this very simple classification problem. We just ran it to see how bad it is. It's not a segmentation result here, it's classification. So part of it is intentionally messed up. But what you see here are the noise patterns that are inherent to these kinds of imaging, right? They do show up in classification results as ice artifacts. So in the original image here, we have the effects of wind. There is no ice here. There's no clouds. This is really wind roughing up the water surface. In our label, there is no ice here, but in our prediction, we see a lot of, let's say, first-year ice showing up as an artifact. And again, that's the model getting it wrong, partly because we also use a very simple classification model, but partly because of this noise pattern. You should perhaps see this line on your screen, right? So these images are noisy. Without going into too much detail as to what these noise patterns are, you see these vertical lines and these horizontal lines. And then we thought, okay, we have some okay denoising methods. Maybe we can generate training samples, and then using an autoencoder, or should I say encoder-decoder convolutional neural nets with skip connections, we could denoise these. The idea was, well, will we get better than the original training samples? And our experiments show that the model does generalize okay, right? So if you're imaging over open water right here, this profile where I'm moving my pointer should be a flat line, not something like this. And you see that after we denoise, the profile does become closer to a flatter line. But this is not there yet. We need to work on this a little more because we are using this as a post-processing method, and especially if you have skills with Linux and working with our research computing Alpine instance on campus. This is a new, should I call it a supercomputer? A new GPU research computing center resource that we have the data and the models on, and we would love to take this a bit further. It's good for research purposes right now. We are not really ready to deploy this for operational purposes. So that's a potential topic for you. And in this case, again, the data is more or less processed through NumPy arrays, so you don't really need a whole lot of GIS skills there. There are other challenges with this CIS project. I'm just gonna use this one as a segue to my next project, interactive learning and labeling, right? So when you have weather forecasting, for instance, there is a human doing the interpretation, right? So all sorts of models and visualizations, the output, a human is looking at those and interpreting them. And in this case, CS is a very challenging target to do classification and mapping of. So can we generate an interactive system in which part of the labels are generated automatically, and then the user or the expert can look at it and using batch or single label efforts, single label corrections, improve the system over time. Or take one initial model and then train it for the freeze-up season, for the melting season. We do have access to those experts. What we don't have is a system for this kind of approach. So if you're interested in developing human-in-the-loop systems, that is something that I'm actively thinking about implementing for this project. In fact, I've tried to propose it to a couple of organizations, and there has been a conceptual interest in this. And there is another challenge that I haven't really talked about. There are, there's the grid-based data, but there's also track altimeters that don't really capture an image, but just a track. So imagine an image, a 2D image, plus a 1D line. And how do we fuse these data sets? Because for this particular line, we know that incorporating this data set will improve the results. But what do we do about the rest of the image where we don't have the track? This is very preliminary thinking. We haven't really done much, but again, a very unique problem. No cat and dog or MNIST or fashion data set here. I'll use that as a segue to who I used to be. I say used to be because I didn't get a lot of funding for my interactive interactive human-in-the-loop visual analytics work until recently. So hopefully I'm going to step back into it. And really the idea of visual analytics is that the analytical reasoning facilitated by interactive visual interfaces, right? Models and algorithms only go so far. Almost always. Sometimes you have real-time scenarios in which the output is not acceptable enough. And visual analytics systems comprise of these things, of models in the backend, plus interactive interfaces in the front end that help a human or an expert, be it your audience or the expert, to interact with the data or the model through that interactive visual interface, right? Now it can be for actionable for actionable scenarios in real time, or for decision making, or for scientific analysis, right? And it's also really helpful because then we can actually put our research in the hands of people who use it, not just publish papers. And really good for dynamic big data that changes over time. An example of this was, the social media analytics-based situational awareness. This particular project came actually out of CU Boulder, right, back in the day. But for a good while, Twitter was being used to both crowdsource instances of crisis and as well as send alerts to the crowd. So a two-way communication system. But at some point, first responders realized, oh, they can actually get a whole lot of information from Twitter if that stream is harnessed correctly, to then be able to gain situational awareness 10 minutes before the first person calls, right? So this is an old project that I worked on before joining CU Boulder, back in the day when Twitter was a little more active, getting the stream of Twitter data, doing some topic modeling in the back end, but lots of interactive UI development in the front end to make this useful to a first responder. And there were interactive machine learning algorithms built in too, so they could click on certain tweets or certain keywords and call it relevant or irrelevant, because we realized keyword filtering was only going so far. It wasn't really helping with weeding out all the irrelevant tweets. But if you had a very specific scenario, you could train the system by clicking on 100 tweets. By 200 tweets, you will reach an accuracy of 80 to 90% usually. I haven't done much of these recently, but if you have UI development interest, visualization interest, We will have more of these coming up. We do like to implement something like this for the CIS project, right? Allowing a CIS analyst to work with the models in the back end, but also we are starting a new project with the National Renewable Energy Lab, interactive machine learning for energy systems. I might not be ready to put someone on this project right now, but I'm just putting it out there because, you know, again, if you connect, there is a very good chance of this project continuing and renewed funding in the follow-up years. If, you know, if you're a master's student thinking about switching to a PhD and working with us and NREL, this will be a tremendous opportunity. I don't have a whole lot to talk about right now. We just signed the contract. The project is started 2 weeks ago. Just want to acknowledge our previous lab members who contributed to what I presented today. Our lab has grown a little more than what you're seeing in there. So we've had 3 other students and 1 new postdoc joining us. They're not on this slide. So it's not a comprehensive list, but I wanted to give you an idea that the work that you saw was not just the work of one person, and you know, the expectations are always realistic. With that, I am going to pause and see if I can take questions and interact with you all.
You guys can either post questions on chat or raise hands and unmute yourselves and ask.
Yeah, thank you. I think unmuting yourselves will be good. This is much better, by the way, than you sending an email later. Still send an email later, not a problem. I will be slow in getting back to you. This next couple of weeks are crazy, and I'm 900 emails behind. Your question might be your friends, your folks and colleagues' questions as well. All right, let me pause this. Oh, you have a raised hand, Abraham?
Hello, Professor. Really interesting and nice presentation. Thank you for that. During the presentation, a few times you said that a certain project who might need like certain GIS skills. Can you like briefly go over that? Like what scale or what level of skills we might need?
That's a great question. So we do have GIS courses on campus, but you know, obviously we are in the 3rd week of the semester, and you might have already planned this semester. There are free online courses that kind of help you with the preliminary skills that you need for this kind of project. So Esri is the company which is kind of the Microsoft of GIS, so to speak. It has locked in utility companies, local government, federal government agencies. And we do get through campus free license to ArcGIS and ArcPro, and you can download and run it. Unfortunately, only on Windows, otherwise you need a virtual machine. And we have side licenses. Well, now why am I going on Arc? I want to say because it's a commercial product and they want to lock people in, they have excellent courses online for free. I want to say you need introductory skills to GIS. So if you have never heard the word shapefile, right, then I'll be very wary of putting you on a certain project that needs GIS skills. Or if you've never heard of the word projections for that matter. I want to say just intro to GIS is more than sufficient, because really what we are researching is not hardcore GIS. We just need GIS to do data processing. Our research space is usually in the deep learning space, or the application of deep learning, or the human in the loop visualization, visual analytics kinds of things, right? So there are other colleagues of mine who, you know, usually don't recruit out of computer science. Their research projects are hardcore GIS, for instance, how to do distance calculation on slope terrain, right? Or how to do location allocation with uncertain source and destinations. Those are very GIS specific topics. Does that answer the question? So for you need enough GIS data skills to just wrangle with the data, visualize it real quickly, clean it, get it into your framework for learning. For the COVID project, you don't really need GIS skills. For the CIS project, for segmentation, you do, at least, again, unless you're starting next semester, in which you have some time to build that up this semester. If you're interested in picking up the denoising autoencoder, most of the data that we have is already processed for you. For the air pollution downscaling, I want to say also some GIS skills, but not a whole lot. Yeah. Other questions? And the COVID forecasting problem, it can be 5 different projects on its own, by the way. So if 5 folks say, hey, I'm really interested in that, then I'll talk to you about the very specific research questions that we have identified as gaps in the domain. Not we, we've been attending CDC meetings for a year now. Well, actually 2 years, lost track of time. And we have identified as a collective where the research gaps are, and that's where I would point you to as your research project. Other questions?
Can I ask one more question?
Absolutely, go ahead.
Okay, so for the CIS mapping project, doesn't that project, does it involve working with NetCDF files?
It's a great question. We do work with NetCDF files too, yes. Not just that. Yeah.
All right.
It's a newer format, yeah, great. Again, actually, that's an interesting point you're bringing up. Most our students and postdocs, when they start working on this project, they haven't played with NetCDF yet, but they know GIS principles, and it's yet another format you loaded because you know the GIS principles, we can work with them. I personally, this is a bad confession to make, I have never worked in my own coding with NetCDF. I do less and less coding these days because there are research teams that I need to lead and proposals and that kind of space. But NetCDF is a more recent data format that our team is finding itself having to work with in the cloud.
Okay, great. That helps. I actually had some experience with NetCDF and working with satellite data. And it was kind of similar to the CIS mapping. So just asking. Thank you.
Of course, you're welcome. Again, CIS mapping, anyone comes and says, this is what I'm interested in, and this is my background, this is the skill set that I do have, then I would be looking and identifying potential research questions with potential data sets. We've been involved in this field for a couple of years now. So we know where, for instance, if an already processed training data exists for someone to go and do some sort of contribution. One thing that I haven't talked about for CIS is multi-source segmentation, right? So we have the SAR data that is very high resolution, but we also have lower resolution passive microwave data, and there's a data set that's already processed all of these. And you have the labels as well, right? I still haven't seen anyone writing a paper on, well, can we fuse these 2 data sets, these multi-source, essentially convolutional, most likely approach? Does it improve our results? Doesn't it? It might be that it wouldn't improve the results, and that will be the answer. It's a kind of field that the null findings are still findings, because they're newer. A lot of folks are interested and reporting on something that doesn't really improve the results in its own. It's something that the field is interested in. I was told as much by the National Science Foundation program officers last week to report on even cases where we realize, oh, there's too much noise, or this is not working, because they want to know. Otherwise, folks like me will write a proposal and say, look, we're going to apply deep learning to these images and everything will be perfect. In reality, that rarely ever happens in the spatial data. In the remote sensing domain when you have moving targets. So, other question, what do you look in master's students for someone who's interested in the projects that you presented but has no notable prior background in the field? Is there something we can make up so that we could be part of your projects? That's great. So we usually look and see how good you are, how this can benefit your career. And once I have a better understanding of what courses you've taken, what your training is, then I will be trying and finding a candidate that best serves your skills. Part of it is going to be learning, right? But we want to balance the learning versus research part. We don't want you to go take 2 years of courses just for this one project. So that really depends on the person. For a master's research project, you know, my approach to this is usually something comparable to one conference presentation or journal publication. And I should say, when I say conference, I'm not talking about a first-year computer science conference, right? So that's one thing. And my job is to put you somewhere at the beginning that I know has that kind of potential. And how can I find a problem for you that matches your background with a little bit of learning that has the potential for you to get results. It will be a learning experience first and foremost. You know, if you were competent, I don't know, if you were ready to go researchers, you either be in your PhD program or most likely you will already be a professor. So don't worry about it. Doing it is part of it. And if you decide that you do want to, yes, please do send an email with your CV potentially. Resumes are kind of vague and hard to read, but resumes work too if that's all you have. And explain the courses, what you're good at, what you perhaps aren't good at. We can start a conversation, potentially even meet, and take it from there. And if there are projects that you have in mind that you are interested in, but wasn't part of what I explained, I typically say no to most of those, but if I see something that is in line with my interests and the work that I do and adds, really, it means that I'm qualified to supervise. That's what I'm saying. I'm actually open to those as well. I find myself these days with so many projects that I say no to most of those. But if you see something that kind of connects with the themes I presented on a different domain, right? Not CIS, maybe you're doing land cover, or I said graph neural networks, but you have your own family of models you're interested in. Do feel free to bring it up. Otherwise, if there are no questions, we can call it a session, huh? Or everyone's very shy always.
Sure, I guess we can. So thank you once again, Morteza, for your time, and I'm sure students will be reaching out to you. We usually tell students to kind of write up a research statement as well before reaching out to faculty so that they have put some thought, done some homework before they just reach out. So again, I'm sure we'll be following that. And thank you once again.
Thank you. There is a question, or is that a clapping? Oh, it's clapping. Thank you. I applaud you all back. Have a good rest of your day.
Bye.
Bye-bye.